Hi, it's Jo Karen Hudson speaking with you today about exponential expressions and the product rule. Let's start with the definition. An exponential expression must have a variable, maybe x, raised to some exponent, maybe a 2. Exponential notation involves writing a base raised to an exponent, maybe b to the x, where b is the base and x is the exponent. Coefficient. The coefficient is the number that is multiplied by the base. For example, on 4y squared, the coefficient is 4. It's the number. So we want to identify the coefficient, the base, and the exponent in each expression. Starting off with 12y to the 7th. The base is y, the coefficient is the number in front, it's 12, and the exponent is 7. Our second example, the base is x, the number out front is negative 1/2, it's the coefficient, and the exponent is 3. And on our third example, 2.5y to the 4th, the base is y, the number out in the front, the coefficient is 2.5, and the exponent is 4. Okay, write an expression in exponential notation. So we have 3 times 3 times 3 times 3 times 3. In other words, 3 is the base, and it is used 1, 2, 3, 4, 5 times. Our second example, negative 5x is the base, and the base is used as a factor 1, 2, 3, 4 times. Okay, let's evaluate the following expressions. Example 1, we want to evaluate this expression. And we can use our calculator to help us with that. We want to type it in exactly as it is in the problem, negative 2, parenthesis, raised to the 4th, and that turns out to be 16. Negative 2 raised to the 4th turns out to be 16. Now, our second example does not have the parenthesis, and I want you to see what a difference that makes. It does make a difference when it doesn't have the parenthesis. If I type it in without parenthesis, negative 2 raised to the 4th, see, I get negative 16. You have to be careful to type the problem in exactly as it was written. Exactly as it was written. Okay, continuing. Evaluate the expression 5x to the 3rd when x is equal to 2. So we'll start off by wrapping our 5x to the 3rd. We want to wrap our variable in parentheses first before we substitute the 2. So we will change that to 5 times 2 raised to the 3rd. Now, using the calculator, we'll have 5 parenthesis 2 parenthesis raised to the 3rd, and that gives us 40. Now let's look at it when we do 5x to the 3rd and we substitute in a negative number. Let's see what difference that makes. So we're going to write down our 5x to the 3rd. We're going to wrap our variable in parentheses. We're going to type in 5 times negative 2 raised to the 3rd, and then we'll look at that. So we have 5 parentheses times negative 2 raised to the 3rd. This one gives us negative 40. So I'm trying to emphasize the importance of typing it in exactly the right way. This one gives us negative 40. Okay. The zero exponent rule. Any non-zero number raised to the zero power is 1. Example 1, negative 5 raised to the zero power. Now notice that this one is in parentheses. Negative 5 raised to the zero power. That is in parentheses. So when you type it into the calculator, you want to make sure that you type in parentheses. Negative 5 with parentheses raised to the zero power. And you see that's equal to 1. 14 to the zero power. 14 to the zero power. Let's type in. Now let's type it in exactly as it's written. Don't add anything that's not there. 14 raised to the 0, that's also equal to 1. All right, let's go on to the third one. Negative 6 raised to the 0. Negative 6 raised to the 0. Typing it in exactly as it's written, and that's negative 1. You see, it makes a difference whether there's parentheses or not. On this particular one, you see there was parentheses on example 1 and there were not parentheses on example 3. It gives you a different answer, and that is because the exponent only bosses the base that it's sitting on unless there's parentheses there. That's the reason the 6 to the 0 turns into the 1 and the negative out front makes the answer negative. Okay, here is our last example of this. Negative 9 raised to the 0, that's 1, plus 8 raised to the 0, that's 1, and 1 plus 1 is equal to 2. And you can put that in the calculator and you'll find you get the same result. Be sure you type it in exactly the way it's written. All right, let's go on with polynomials. A polynomial is an expression that has one or more exponential expressions that are being added or subtracted. The exponents must be whole numbers, not negatives. They can be fractions in the coefficients, but not in the exponents. There can't be variables in the denominator. So polynomials are easy to work with. The highest exponent is called the degree of the polynomial. Terms are the parts of an expression that are added or subtracted. The leading term is the term with the highest degree. The leading coefficient is the coefficient of the leading term. A constant term is the term without a variable. A polynomial is classified as a monomial if it has one term, a binomial if it has two terms, and a trinomial if it has three terms. Polynomials with more than three terms are simply referred to as polynomials. Now, for each of the polynomials, we want to give the number of terms, the class, the degree, and the leading coefficient. So let's start off with this first polynomial, x cubed. The number of terms, let's see, there's 1, 2, 3, 4 terms. Terms are separated by the pluses and the minuses. There's 4 terms. The class is a polynomial. The degree is the highest exponent, so it's degree 3. The leading coefficient is the number in front of the leading term, so it is a 1. It's understood to be a 1 if the variable doesn't have a number written in the front, and the constant term is the one without a variable, and it is negative 1. Okay, example 2. 5x plus 2. There are 2 terms here. It's classified as a binomial. The degree is 1. There's not an exponent. It's understood to be 1. The leading coefficient, the number in front of the leading term is a 5, and the constant term is the 2. The one without a variable. And here we have our third one. The number of terms is 1. It's classified as a monomial. The degree is 0. There's not an x on it showing, so it's like having x to the 0. The leading coefficient is 7, and the constant term is 7. Okay, that ends this video. It's Jo Karen Hudson speaking. Thank you, and have a wonderful day.